right, today we are going to move on to day 2. We are going to solve systems of equations by substitution. Okay, so that's going to be our new method. The first section we were graphing them to find a solution. Today we are going to do what's called substitution. So I want to start with this definition. Zoom in a little. Excuse me. Solving systems by substitution. So what we're doing is we are substituting an expression in for a variable. Use this method when you have a variable that is easy to isolate. So go ahead and pause this video right here. I'd like you to write that definition down and then come back when you have it written down. Okay, we are using more of an algebraic approach versus a graphing approach to solve. Now, I do just want to remind you, we do have these 3 items. We still are going to primarily get one solution. Remember, that is going to be an ordered pair. So graphically, it's the intersection on a graph. Today, we're going to end up getting one value for x and one value for y with both equations. Sometimes we do get a no solution, okay? And so we will see what that looks like here today. Same with infinitely many solutions. Okay, let's take a look at this first example. Solve by substitution. Remember, solutions are intersections of 2 lines. So write them as an ordered pair. That should really be a comma. Write no solution or infinitely many solutions where appropriate. Circle your answer. All right, here's what I want you to notice. I have got y equals x plus 8. I have y isolated. The second equation is x plus y equals 2. So I want you to see that I have y equal to something. But wherever I see y in the second equation, I can plug that in. So I'm going to take the expression of x plus 8 and plug it in below here. So I'm going to be able to do this. I'm going to do several colors here. I'm going to be able to do x plus, and then I'm going to plug in x plus 8 in place of y equals 2. Okay, so I want you to see here is that all I did is I replaced the value of y in the second equation with x plus 8 above because it was equal to y. Okay, it would be the same as if it was this. Let's say I were to just have y equals 8, and then the second equation said x plus y equals 2, well then I would just take 8 and plug it in place of y and then solve. I'm doing the same thing here, it's just I'm plugging an entire expression in. All right, so I put parentheses around this because sometimes we do have something to distribute in. But since it's only a 1 in front of here, I can really rewrite it without those. So x plus 8 equals 2. And then notice the y is gone. So now I can combine like terms and solve. So x plus x is 2x. And then I just want to keep going. So I'm going to take away, let me switch colors here with you. Take away 8 from both sides. And then I have 2x equals negative 6. And then I'm going to divide by 2. And then I'm done with my value of x. X equals negative 3. Now, I am going to do this. My answer is going to be an ordered pair. Well, I already know the x value is negative 3, so let's go ahead and put that in there. So I want to take negative 3 and plug it into one of the 2 equations at the top. So I'm going to do this. I'm going to circle x minus 3. And I'm going to come up here, and I'm going to plug it right there in place of x. Okay, so I'm going to do y equals, I'm going to work with this equation, x plus 8, but I know x is negative 3. So I'm going to plug in negative 3 for x, and then all I have to do is add those 2 numbers together. So negative 3 plus 8 equals 5. So I know my answer is negative 3 comma 5. So this is called substitution because the substitution occurred at the very top the first time. So I plugged one expression in place of a variable below. Then I got the answer for one of my variables, and then I plugged it back in to get the other. Oops. Lost my page here. There we go. All right. Okay, let's look at number 2. Solve by substitution. So what I see here is x equals 2y plus 1. I already have x isolated. So I'm going to take 2y plus 1, and where I see x in the second equation, I'm going to plug it in place of x because that's truly what it's equal to. All right, so I've got 2y minus, so plug in what you're plugging in for x, 2y plus 1, and then the rest of the equation says equals 3. Okay, so I still have 2y minus x, it's just I plugged in what the value of x was. Okay, now the parentheses is pretty important here because there's a negative 1 in front. So I do need to distribute that negative in there. So 2y, now multiply that negative 1 in, minus 2y minus 1 equals 3. Let's combine like terms. So 2y minus 2y, that's 0. So what I'm left with over here is negative 1 equals 3. So my variables have dropped out. So let's go up to this graphic. It's going to be one of these two answers. It's either a no solution or an infinitely many. So when I look at that, I ask myself, is that true or false? Okay, that is false. A negative 1 is not equal to 3. So if it's false, it's a no solution. If it were true, it would be infinitely many solutions. Okay, so that's when we'll end with a no solution, when your variables drop out, and this is not a true statement. Okay, well, let's just keep going. Number 3, solve with substitution. Okay, I see both variables, or I see y equals and y equals. So I can still substitute. I can still take what y is equal to in the top equation and plug it into y in the second equation. So it's going to go right there in place of that y. So my new equation will read 4x minus 18 equals 2 minus 6x. So you could also say, well, if the two y's on the left are the same, then the two expressions on the right are the same, so I can set them equal. Okay, let's solve for x. I'm going to first move the x term over. I'm going to add 6x to both sides. So I've got 4x plus 6x gives me 10. So 10x minus 18 equals 2. These guys add up to 0. Now I'm going to take care of the negative 18. So I'm going to add 18 to both sides. Negative 18 plus 18 is 0. So 10x equals 18, 19, 20. Now divide off the 10. So I get x equals 2. Okay, so I'm not going to get a no solution or an infinitely many. I'm going to get an ordered pair. So let's start our answer out. I got 2 comma something for y. So it doesn't matter which equation you plug 2 in. You could go to the top one or the bottom one. So I'm just going to do this. I'm going to take my 2 and I'm just going to go up to the top and drop it in place of x right there. All right, so I'm going to plug it into the top one, 4x minus 18. So it's going to say y equals 4 times the 2 that I got, minus 18. And then now I just have to simplify the right. I'm not really solving an equation, I'm just simplifying. So 4 times 2 is 8. So I'm doing 8 minus 18. And then 8 minus 18 is negative 10. So finish your ordered pair. And so your answer is 2 comma negative 10. Okay, well, let's keep going. We've got a couple more, and then we have a couple word problems. Why don't you maybe pause the video and try 4 and 5. Let's see how far you can get. And then when you get stuck or when you get finished, come on back to the video and watch me go through these problems. Okay, what I see here is my isolated variable is in the second equation. So I'm going to take this whole expression, plug it in place of y at the top. So it's going to go right there in place of y. So it is going to read x minus 4 times y. Now let's plug in what y is equal to. It is equal to 1/4 x plus 2. And then now write the rest of the equation out, equals -8. Okay, now I'm going to distribute and solve for x. So I've got x, and then I'm going to distribute my -4 in there. So that's going to be -4 times 1/4 is -1. So minus 1x, or just x. -4 times 2 is -8. X minus x is 0. So I now have 0 minus 8, which is just -8, equals -8. So it's either an infinitely many or a no solution. So this is a true statement. So that means all of the numbers are correct. So infinitely many solutions. So what that means is I can plug anything in for x and y above. I'm always going to get it to cancel out to be -8 equals -8. So it doesn't matter. Every number works. Okay, number 5. My isolated variable is in the first equation. So I'm going to take y plus 9. It is the same as x. So it's going to go in place of x here. So I'm going to do 2 times. So plug in what x is equal to, y plus 9. And then the rest of the equation says minus y equals 3. And now we have all y's. So let's distribute. So 2y plus 18 minus y equals 3. And then let's combine like terms. 2y minus y. So 2 minus 1 is 1. So that leaves me with y plus 18 equals 3. So now I'm going to move the 18 over. Take away 18. Take away 18. 18's add up to 0, so y is equal to -15. All right, ordered pair, I know the y value. So I'm going to take y equals -15, and I'm going to just come to the top equation and plug it in right here. So I will have x equals, so I'm using x equals y plus 9. I got -15 for y, so plug it in. And then again, I'm just sort of simplifying over here. -15 plus 9 is -6. So I'm going to drop my -6 into my ordered pair here. And my answer is -6, -15. Okay, so that's the substitution method. We do have 2 word problems I want to go through. So I'm actually going to stop this video here and then make a second recording with just the 2 word problems. So go ahead and move on to that next recording so we can set up, and we're actually going to set up and solve this time on the word problems.